and experience to the position and his 10 years plus of conservation in management and research as a Pu'uwa'awa PWW coordinator with the DLNR DOFA, DLNR Department of Land and Natural Resources, Division of Forestry and Wildlife. He has a PhD in fish and wildlife biology from the University of Montana, and has also worked with the Three Mountain Alliance Watershed Partnership on Hawaii Island. Dr. Parsons most recently led the Napu Conservation Project in North Kona and teaches both undergraduate and graduate wildlife science courses at the University of Hawaii at Hilo. Today, Dr. Parsons is the new specialist for the Pacific Regional Invasive Species and Climate Change Management Network. Please welcome Dr. Elliot Parsons.
Mahalo nui for the invitation. Can everybody hear me? Thank you so much for the introduction. I'd like to thank Dr. Price for the invitation to come speak with you all and share about Pacific RISC and what we're up to. And I want to start off by thanking our leadership team for Pacific RISC, all the names below and the logos representing all the institutions. It's a great pleasure to work with everybody on climate change and invasive species. And I want to start off by thanking my funders. So funded by the Pacific Islands Climate Adaptation Science Center and the U.S. Fish and Wildlife Service and UH Manoa post my position. As Justin mentioned, I spent some time at Pu'uwa'awa. Was my previous position with DLNR Forestry and Wildlife. I was a manager for about 12 years in North Kona of this amazing forest, and I really got to know invasive species. There are a lot of incredible native species there, but there are huge areas where the non-native species dominate. And as I found out the hard way in the beginning, getting rid of some of these non-native species can be a challenge. When I first started, we were trying to get rid of fountain grass with Pulaskis, which I don't recommend. It's not good on your body. All weed whackers are maybe a little bit better on your body, but I definitely learned a lot about different tools and trying to learn how to control invasives and restore endangered dryland forest ecosystems. And what I realized working there for 12 years is that in large areas, the weeds have really completely taken over or are threatening to do so. And it's a huge challenge for maintaining any semblance of native biodiversity in large areas. And so the question that we're interested in with Pacific RISC is how will climate change affect invasive species in the Pacific region? And by invasive species, I'll use the definition from the most recent federal US executive order. So a non-native organism whose introduction causes or is likely to cause economic or environmental harm or harm to human, animal, or plant health. And in the Pacific region, we know that invasive species are driving the conservation crisis. We have invasives in pretty much every ecosystem from many different taxonomic groups. And the density is much, much higher on Pacific Islands than is compared to continental areas. So this is a USGS report from 2018. And the dots represent non-native species richness. So each one is a non-native species. The squares represent per 10,000 square kilometers. And so you can see the comparative density for Alaska and the conterminous US. When you compare it to Hawaii, our density is about 200 times higher. And it's really hard for continental audiences and researchers, I think, to really grasp this. And we know that invasive species have a variety of impacts. They impact, of course, native biodiversity, native ecosystems, but also have really devastating impacts on agroforestry systems, on food security, both terrestrial and aquatic and marine systems, agriculture. They affect our ability to have sustainable livelihoods. They lead to loss of cultural practices and traditions. And they lead to losses of really important ecosystem services like groundwater recharge. On the biodiversity side, we know that they play a large role in leading to native species declines and extinction. So the brown tree snake is one of the notorious examples of a non-native species having really detrimental impacts. And the brown tree snake is basically almost the sole cause of 10 of the 12 native bird species on Guam becoming functionally extinct in the wild. And a recent report that's well worth checking out was the first comprehensive global report on invasive species, and it came out last fall. And they had some really good take-home messages in the executive summary, but one of those, invasive species have played a role in 60% of global species extinctions and are the sole driver of 16% of reported extinctions. So invasive species, in particular in the Pacific region and on islands, really play an outsized role in their negative impacts to native species and native ecosystems. Impacts are increasing and the costs of those impacts are increasing. And so this is a study that came out last year that we reviewed for Pacific RISC. One of the things we do is we review articles and we send out short summaries to those on our listserv. And biological invasions are in red. And you can see since 1980, the costs increasing compared to other natural hazards. Floods, drought, wildfire, landslides, volcanic activity, and biological invasions have shot to near the top. Basically, the second costliest natural hazard worldwide, just underneath storms. What does it look like for the Pacific region, for Pacific Island countries and territories? The proportion of costs is about 40%. About 12.6 billion since 1980. That's compared to about 21.1 billion for all the natural hazards combined. Invasive species aren't often thought of as a natural disaster, but there's really good reason to think of that as in comparison to these other really large and important natural hazards. And unfortunately, species are still arriving. And they're arriving at a fairly steady rate, at least for some taxonomic groups. This is a recent paper by Dr. Kelsey Brock, who's a professor in Wyoming, and Professor Kurt Daler, and it shows the number of naturalized plants in Hawaii since 1900. And it looks like a fairly strong linear increase, although it looks like the rate might have gone up in just the last few decades. And naturalized plants are plants that basically they get here, they establish, and they're spreading on their own without humans needing to help them spread. So they're doing it on their own. The average rate that Dr. Brock found was 10 to 12 new naturalized plant species being added in Hawaii every year. And when we break this down into intentional versus accidental introductions, we see that a large portion of the current introductions of these naturalized plant species in Hawaii are intentional. And so as one of my colleagues put this, and I really like how she put this, she said, we are doing this to ourselves, right? And it's both good news and bad news, right? It's bad news because look at that curve, but it's good news because we can do something about it, right? We can enact policy measures and try to reduce that intentional introduction. But invasive species, of course, aren't the only picture. Climate change is really important, and that's where Pacific RISC comes in. We know that the climate in Hawaii is changing. from impacts ranging from warming and ocean acidification, sea level rise. The severity and frequency of drought is increasing, severity and frequency of wildfires is increasing. And we have long-term changes in rainfall and projected changes in, with climate change in the frequency and timing of rainfall. And we can expect from recent models an increase in storm intensity. And so one question folks have had for a while is, how do climate change and invasive species interact? And this meta-analysis was done a couple of years ago, and they looked at many different studies, and they wanted to ask, what are the individual and interacting impacts of climate change and invasive species? And what they found is that in about 30% of the cases, the impacts were synergistic. So they were either worse than expected or better than expected based on the individual impacts of either invasive or climate alone. And what that means is that we really need to get a better grasp of how climate change could impact invasive species, because as we know in Hawaii, landscape scale invasive species management is really costly, it's super expensive, and it must be strategic. The recent National Climate Assessment came out, and Chapter 30 and for Hawaii and US affiliated Pacific Islands, I wanted to share this one quote, and it's definitely well worth checking this out. But in key message 4, they said interactions between invasive species and climate change in isolated Pacific islands are complex, which we're going to be talking about, with climate change most often exacerbating invasion. And that's the big worry, that climate change is going to make things worse. And when managers are already strapped for time and money, and they're already kind of at their capacity or past it, it's not a message we want to hear, right? And so we really need to think about how can we be more strategic with our resources, and what can we change, what can we improve? And so you might be familiar with the stages of invasion. I'll just go over this really quick. Invasive species go through these different stages before they become invasive. So they need to be transported. That's part of the human modification or movement requirement. They're introduced to a new area that they're not native to. They establish, they spread, and then they cause impacts. And that's kind of the basic stages that invasive species go through. And so climate change could affect multiple stages. So climate change could affect the pathways that invasive species take to get here, especially with Arctic potentially opening up. We might have new areas and new species, new propagular pressure. But also increased disturbances could be fairly important, especially with the expected increase in storm severity. Higher climatic suitability, so that's something I'll be talking about in a minute, could lead to greater establishment of certain species. There's a question about, can invasive species respond more rapidly to climate change than native species? And there's a number of reasons to expect that that is the case. One of the big theories about why species become invasive is they've escaped their natural enemies, and that might give them the ability to have higher population abundances and maybe more rapid spread, for example. And then impacts could change as well. So we could expect potentially increased abundance, density, and impact of invasive species. You probably recognize the strawberry blobber picture. And so how do we address this growing threat in the Pacific region? So the Pacific Regional Invasive Species and Climate Change Management Network, or Pacific RISC, was established in 2019. And we've expanded the last few years to include jurisdictions from all of the US affiliated Pacific Islands, in addition to Hawaii. And we've got a great team of folks helping to drive this program and what we're doing. And this is our area. Pacific RISC area, it includes the US territories in the Pacific, as well as the affiliated independent nations. And it's a large area. It's larger than the continental United States. It includes over 20 spoken languages and over 2,000 islands. So it's a pretty big region. But we're not alone. There are other risk networks. So you can see Pacific Risk on the bottom. The Northeast Risk was the first risk, and it was a wonderful model for getting managers and researchers together to talk about these issues. And so it spread to different regions, and now we have risk groups around the United States, and Canada has recently set up their own version of risk. And so two of the questions that we are asking and trying to determine how we can address these, how can we best adapt invasive species management to a changing climate? And how can we best incorporate invasive species considerations into climate change plans, guidance, and policy? And a cursory look at some plans shows that that climate and invasive species management, they're largely siloed. They largely don't interact with each other. So a lot of climate adaptation plans don't really address invasives at all. A lot of invasive species management plans don't really think about climate. And so we really need to figure out how we can bring those together. And one more point on that for anyone on Big Island in 2014, when the hurricane hit and all the Albizia came down all over everything, that was a big wake-up call that we do need to take into consideration, especially invasive species with storm events. And so what does Pacific Risk do? A number of things. We facilitate this large network of folks. Please join our email list. I have flyers in the back by the food if you're interested. We work to create a space for engagement, bringing people together, especially managers and researchers. We're working to develop ways of sharing information. And so one of the ways we do that is through these research summaries, which I mentioned a minute ago. A lot of people don't have time to read papers, and so we really create a shortened version to try to get take-home points and management considerations and get those out to the people that need them. We want to promote relevant research. So when we see something that we think is really good, we try to share it out with everybody. Share successful strategies and approaches, especially through workshops, which we've done a couple of. And what we'd really like to do in the future is prioritize lines of research. And so try to come up with important research gaps and then see how we can fill those. And so I want to take a slight pivot for just a second and talk about the need for boundary spanning organizations. And so Pacific Risk is an organization that spans boundaries, management and research, peer and applied. There are all different kinds of siloed groups that really need to kind of connect and get together. This was a study done almost 10 years ago. And what they wanted to do is they wanted to compare, they wanted to ask, is the research that managers need getting done? And so it's divided into basic research on the left and applied on the right. You can see the different topics: succession, seed banks, species ranges, herbicides. And then the zero line, if you're on the zero line, it basically means that the research that is being done matches what the managers want. If you're to the left of that line, that means there's underrepresentation of topics in the literature. And then if you're to the right of that line, that means there's overrepresentation of topics in the literature. And so what it shows you is that the research that's being done doesn't necessarily address the needs of managers. Underrepresented topics, seed banks is a big one. And of course, that's a huge topic right now with fires. Life history, dispersal, spread. For some reason, a lot of research is in the other category. I don't know what researchers are studying, but it must be interesting. And then when you look at applied, you see the same pattern. There's a bunch of really underrepresented topics: timing, negative consequences of invasive species, herbicides. And then there's some big ones that everyone wants to work on: biocontrol, manipulation of resources, and then the other category again. And so the research that we need is not necessarily getting done. And so we need to come up with ways of getting that work done. It needs to be done to answer the questions that managers need to be able to address both invasive species, but in a changing climate as well. And so in 2021, Dr. Laura Brewington led this manager survey. And managers across Hawaii were asked, what are your priority climate research topics? And as you can see, there are a lot of them, but the top one, which I want to talk about in a little bit more detail, is range shifting species and hotspots. So this was the number one thing that managers wanted to know with climate change and invasives. How are invasive species spreading with climate change, either now or in the future? Right? And so when we think about range shifting species, a lot of work has been done recently on this topic. And species are expected to move in 3 basic ways with climate change. And we'll make this more complicated in a few minutes. Species are expected to move towards the poles, following their temperature niches. Species are expected to move up in elevation, same thing. Or species are expected to move down to deeper marine depths. And the reason is they're tracking their evolved and their preferred temperature and moisture conditions, those conditions that they occur in and thrive in. And there's evidence for a lot of range shifts. So this was a project done in, I think it was 2020, that found evidence of 30,000 range shifts across over 12,000 species. So species are shifting the range across many different taxonomic groups. And you can see on that 0 line, to the left of that 0 line would be towards the equator, to the right of it would be towards the poles, and then for the mountains, to the left of 0 line is down elevation, and then to the right is up in elevation. And as you can see, it's actually occurring both ways, right? So species aren't necessarily shifting as expected, but some taxonomic groups are shifting more according to those climate change expectations. And so I have some schematics to try to explain some different possibilities of what could happen with range shifting in the US Pacific Islands. And then once I set the stage with some of these kind of theoretical expectations, I'll show you what data we currently have and what some of the gaps are. So you can imagine islands of different size. So here we see here a small island, a medium-sized island, and a large island. And then we can imagine there's a species pool that's contributing invasive species, and the little squares represent invasive species A. So maybe those are temperature limited, so they're in some kind of climate niche at lower elevations. I'm going to try to make this as simple as possible just to show some different ideas of what could happen. Sure. So let's say with climate change that temperatures increase, and what happens may depend on island size. So for smaller islands, certain invasive species may be shifted off of that island in terms of their temperature and moisture niches. So we may no longer have to deal with those in the future. So that's one possibility. New invaders are also possible. So in a lot of the Pacific Islands, we're looking at with climate change creating basically novel temperature conditions that don't exist yet in a lot of the lowland coastal areas. So that could open up opportunities for invasives that aren't here and aren't maybe the habitat's not suitable for them now, but it will be in the future. We could see reduced invader abundance. So for maybe small to medium-sized islands that as you go up in an island, the area you have available decreases. And so you could see reduced abundance. And so maybe certain invasive species impacts decrease over time because abundance decreases. And then in this example, we could also see shifts to higher elevation. So for the high islands, for species that are temperature limited, they could be shifting upslope. And this could be a big problem in places like Hawaii, where a lot of our native ecosystems and native species and rare species are currently at those higher elevations. And so if this is something that could occur on a large scale with invasives, we really need to know about it because we need to be prepared for it. But part of this depends on where individuals of introduced species fall within their climate niche. And so there's really not a lot we know about where invasives are and where they are relative to their climate niche. So there are a couple, just to make this easy, there are a couple examples. This first one, you can imagine this climate space. And so the dots have the ability to shift quite a bit because that climate space is large and they're down at low elevations. And so in that case, large range shifts are possible without climate change. You can also imagine that maybe those species are up near their limits in terms of where they might be able to expand. And maybe they can't really go that much farther. In Hawaii, we have the trade wind inversion. So there are potentially limits to how high you can go based on moisture. So that's another possibility. Now let's add climate change to this. When we add climate change, we may not see any change at all in terms of this invasive species, right? So that climate space is moving up a little bit, but that area that it can move is still really large without climate change. And so what that tells us is maybe the species is dispersal limited, it's not. For the ones at the higher elevation, if they are closer to their minimum temperature range, maybe that means they can move up slowly. And then let's do one more simple one with invasive individuals at the center of their climate space. And so these individuals could go up, they could go down. We've actually seen both of those. I remember a study that came out 10 years ago in Yosemite, and it said all these small mammals, they resurveyed the Grinnell transects, which are pretty famous. All these small mammals are like shifting up in elevation, except I think there were one or two that were actually shifting down, right? So things are more complicated. So maybe you can go up or down. With climate change, that doesn't really change anything. You can still go up or down, right? So the big point of this is it really kind of depends, the invasive species, where they are within that climate space that will allow them to either shift and be limited by climate, or maybe they're just filling out their existing space that they haven't invaded yet. And so I want to just throw in one more thing here, and that's thinking about these broad climatic niches for invasive species. So one of the hypotheses is that invasives have these really broad climatic niches, and it's going to allow them to do better in the future with climate change than natives, which might have much narrower niches. And so when we think about that on the top, you can imagine this large climate space that these invasive species are in. And then when you add climate change, you see some kind of a shift in that climate space. Nothing really happens on the small and medium-sized islands, right? Because they have a broad temperature tolerance. Whereas in that last one, the big islands, you may see that shifting to upper elevations. So some questions that have come out of this, all just thinking about range shifting, is where do invasive species occur within their climate niche space in Hawaii? And we don't necessarily have information for most non-native species here. Do invasive species have broader environmental tolerances or niches than native species in Hawaii? And are invasive species more dispersal limited or more climate limited? And now we're going to get into the studies for a couple minutes and we'll be done. And so here's one of invasive slugs in the Hawaiian Islands. And they found with the growth rates increased and time to hatching decreased at higher temperatures for 2 invasive slugs. And so what that tells us is they're not necessarily, those individuals are not necessarily at their temperature optimum, right? And so range expansion is expected for those species because of that. And then here's another one looking at comparing invasive bees to native bees and just demonstrating these really broad environmental tolerances for invasive taxas compared to these small ones for native taxa. And so it could be that a lot of invasive taxa do have these really broad climate niches, and that would buffer them against climate impacts where native species with their narrow ranges might be more effective. So the potential for range shifts of invasive species will likely depend on whether they're more constrained by dispersal or climate. That's a big take-home message, and it's something we don't really understand for a lot of the US Pacific. We have a lot more information in Hawaii, but places like Guam, Commonwealth, the Northern Mariana Islands, American Samoa, we do really have very limited information for a lot of invasive species there. So for evidence for the US Pacific, there are a number of studies that project range expansion for a number of invaders across different taxonomic groups, from bees, fruit flies, mosquitoes, amphibians, mollusks, plants, green algae. And then there are also some that show possible range contraction in the future. For example, plants are a big one, and multiple taxa of invasives on low-lying island. We haven't even talked about sea level rise, right? But for a small island, sea level rise is a big deal. And some invasive species may lose their ranges on those small islands. So our best known example of range shifting due to climate change and warming is of course mosquitoes in Hawaii. Mosquitoes are temperature limited. The species that are here and the ones that carry avian malaria and avian pox. And as the temperature warms, they go to higher and higher elevations where they couldn't necessarily go before. And they have big impacts on these native forest birds, some of which are very susceptible to avian malaria. There was a study done on the EEV, and it was before it became a threatened species many years ago, and it was something like 99% of the EEV died when exposed to mosquitoes with avian malaria. And so as a result, some of these forest birds are expected to go extinct in the next few years as a result of this. Here's another one about plants that I wanted to share, with projected changes in habitat suitability. So this is Moremia peltata, which is a climbing vine. And one of the thoughts that's out there is that vines might become more invasive with climate change. And what you're looking at here is Hawaii, and the red shows highly suitable habitat under the current climate. And they looked at 4 different climate scenarios and found this really big increase in habitat suitability across the Hawaii. But one of the things I wanted to point out is if you look at Lanai, it's not suitable at all right now, but it's projected to become almost fully suitable with climate change. And so it's really something we need to worry about is what suite of invasives are going to become suitable in the future for islands that they're not currently on. And Moremia was spotted on iNaturalist on Hawaii, so it is here now. If we can believe, I don't know if those are research grade observations, but it is a species of concern that we really need to do. This is another study, Vorcino, that looked at invasion hotspots and found that those are expected to increase in Hawaii's upper elevation areas with climate change. And then I'll show you just one more. This was done with for Hawaii Volcanoes National Park for ecosystem modifying invasive species. And a lot of they looked at projected changes within their special ecological areas. So it's kind of like small areas throughout the park. And they found expected declines for a lot of these. And one of the reasons is they're probably up towards their, the top of that niche underneath the trade wind inversion. They don't really have that much space to go, essentially. So things could get better for some high elevation areas, at least in terms of maybe the wet forest or mesic forest invaders that are there. But there was a projected increase in lantana, which is definitely occurs extensively in the dry forest. And so just to wrap this up, I've put out some really simplistic scenarios that you could pick apart pretty easily. And this study, I think, did a good job of that. It was a big meta-analysis that looked at range shifts. It was one of the best I really recommend reading. It's one of the best meta-analyses I've read based on their comprehensive look. And they've basically found that less than half of all range shift observations are moving as expected. And so that means species are moving for different reasons, not necessarily climate change. And so some takeaways for this, Studies are limited. There's very few with empirical evidence. Most are projections of future distributions based on one or more climate change scenario. Mostly are for plants. Most are in Hawaii. There's very few for the US API that we've been able to find. Projected shifts of established species are mainly to higher elevations, especially for those that are temperature limited. Invasion hotspots, especially for invasive ecosystem modifying plants, are expected to shift to higher elevations. There's some evidence, as I showed with Maremia, that whole islands that are not suitable may become suitable in the future to invasive species. Species with broad environmental niches, they could range shift less. That's a hypothesis. We don't really know. It really depends on where those invasives are in relation to that climate space. And then finally, range shifts are likely due to much more than just climate, right? Land use, pollution, declines in native species, large disturbances, moisture, and then of course, with Pacific Islands, dispersal limitation is a huge thing. So I want to finish this with asking this question: how can we best adapt invasive species management to a changing climate? I'm really curious what you all think about this. I made this diagram just to so we could think about this in a streamlined way. We have current management strategies and approaches. Climate change is occurring, it has been occurring, it will continue to occur. It leads to a variety of impacts. And that's going to affect invasive species in different ways. That will lead to changes in impacts, and impacts are a little bit, maybe a lot, in the eyes of the beholder, right? So it depends what you're looking at. Are you talking human health and safety, or talking food security, biological diversity? There's many different kinds of impacts. But those will likely change, as could our perception, right, of which species are bad and which ones need to be dealt with. But ultimately, we're going to have new management strategies and approaches to deal with these changes. And so this is my arm waving at the end. My pitch to all of you, there's a lot of discussion about what climate smart management strategies are, but I want to turn it on its head, and I want to say, what's management smart research? And I want to offer up to you that management smart research will lead to a change in a strategy or approach. And I say this partly having been in management for 12 years before my current position. A lot of the research I saw, basically the conclusions were you need to do more of what you're already doing, and you need more money and more staff. And that's really not going to cut it, right? I mean, we need new options. We need new solutions, and likely we're going to have to do more and more with less and less in the future. And so my question is, what can we change about management that will improve things and help us adapt to a changing climate? And there are many different changes that could happen: monitoring, species target lists, control methods, control frequency, control locations, control timing, restoration approaches, just to name a few. And then finally, and I'll end, I think this is my second to last slide. A lot of this is uncertain. There's a ton of uncertainty in everything. And it's easy to sit on your hands and say, we don't know what's going to happen, therefore we can't do anything about it. You can see this uncertainty in terms of what increases in global temperatures might be. And for Pacific Islands, that uncertainty is magnified because we have such complex topography, especially here in the high islands. And so how do we deal with that uncertainty, right? What do we do so that we start doing something? And then we can monitor it and maybe use adaptive management and think about, are we succeeding? Do we need to keep changing? And with that,